Hello Year 9. So this is for the 3B textbook, Chapter 9A, and this is on transformations. So this is a new unit for you to start working on. So when we're transforming our shape, we're going from our object to our image. Okay, so we start with our object and then we transform it into the image. So one of our transformations that you'll be familiar with already, this is our reflection. Okay, and so for a reflection, what we need is, so to do any reflection, you need a mirror line. So you'll either be asked to complete a transformation using the complete a reflection, using a mirror line, or you'll be asked what the mirror line is, or to describe the reflection that's happened or the transformation that's happened. You need to tell them the mirror line. So in this example here, it's asking you to reflect in the line x is equal to 2. So now you need to figure out which line that is. You know that x is equal to 2 means that the x coordinate is always 2. So the line where the x coordinate is always 2 is here. So that's 0, 2, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, and so on. So that's all the way down there. Okay, so that is your mirror line. Do it as a dotted line. And you can now take each corner of your object and count how far away it is from the mirror line. So this corner here is on the mirror line, so that's not going to move. This one's also on the mirror line, so that's not going to move. This corner here is 2 away from the mirror line. So now we're going to invert that. We're going to do the opposite on the other side of the mirror line. So that's there. This corner here is 1 away from the mirror line in that direction, so we'll go 1 away from the mirror line in this direction. Same with that corner, it's 1 away in that direction, so we go the opposite direction in the mirror line. That one's 2 away, so we're going to reflect that. We're going to go opposite direction in the other way. Okay, then we join them up, so we've got our coordinates now, the coordinates of our shape, and that is our new image. Okay, so this one is the image. So it's after it's been transformed, and this is the object. It's before it's been transformed. So now we move on to rotations. This is another transformation that you'll be familiar with. With this one, you need 3 separate things to be able to complete this. So you need your center of rotation, so the point that it's rotating around. Usually some coordinates. An angle of rotation, so how far it's going. That's one, that's another one. And then we need a third one, which is the direction of the turn. So that's usually given anti-clockwise or clockwise. Okay, so that'll be anti-clockwise or clockwise. In our example, we have rotate anti-clockwise 90 degrees. So we're going to take our tracing paper and I'm going to trace around my shape, like so. So I've got that sorted, and then I need my center of rotation. So that's at 3, 3. So I mark on 3, 3. So 3, 3, that's our x coordinate, and then our y coordinate, so that's 3, 3, which is there. We're going to go round 90 degrees anti-clockwise. So now think about a clock face. Clockwise is that direction. Clockwise is that direction, so we're going to go the other way. Okay, so we take this, we pop our pencil on our center of rotation, and we just turn it 90 degrees to there. So we turn our paper through 90 degrees, then we slowly lift up our piece of paper and mark on where the new points are going to go. Okay. If the shape's changed in any way, other than its orientation, go back and check that you've done it correctly. So it shouldn't get any bigger, it shouldn't get any smaller, none of the sides should really move. Okay. The third and final transformation we'll be looking at in this section is the translation. So for this one, what you need is your translation vector. Okay, so that is the amount that it moves up or down by. Okay, that is the fancy word to tell you how much it moves up or down by. So what you need to do is, if we're translating translate by to -1. So we can see this is our translation vector. That's what we mean by that. Now we need to figure out which one is telling you which one to move up and which up and down, and which one's telling you to move left and right. Okay, so the way I remember this is we have our x and our y. Okay, so the x goes on the top and the y goes on the bottom. Okay, it's alphabetical order, x, y. This is, so we take any x coordinate, sorry, and we add 2 to it. So we take our x coordinate here and we add 2 to it. We take our y coordinate and we subtract 1. So it doesn't matter which order you do that in. So you can add 2 to your x and then subtract 1 to your y. Or you can subtract 1 from the y and add 2 to the x. You get to the same point. You do that with all of them. So taking that point, you add 2 to the y, 2 to the x, sorry, and subtract 1 from the y. Should be crosses. You add 2 to the x and subtract 1 from the y. Alternatively, you subtract 1 from the y and add 2 to the x. You subtract 1 from the y and you add 2 to the x. It doesn't matter which order you do it in. The coordinates help with this type of question because you can see that this corner and that corner, you have 2, 4, and now you have 4, 3. So you've gone from 2, 4 to 4, 3. So as you can see, you can always check. You've got 2, you've added 2 to get 4, and you've got 4, you subtracted 1 to get 3. So this one, in this case, is your image. So that's after you've done the translation, and that is your object. That's before the transformation. So you should be able to see after all of these transformations that your image is the same shape as your object. It is just in a different orientation. Okay, so this one's just inverted, so it's going the other way after the reflection. This one is just in a different orientation after your rotation. And then the translation is just moved into a different place. Okay, so we call these types of shapes congruent. So these are the same shape, so exactly the same shape in a different orientation. Or location. Okay, that's all congruent means. Right, so this question asks you find the center of rotation and the angle of rotation. So you need to determine where the center of rotation is. So that's probably the harder bit. So what we're going to do is we're going to place our tracing paper on top of our shape. So it doesn't matter which one you start with. So sorry, it tells you you're going from the blue one to the green one. So the blue one is this shaded one here. Okay, so that is our object, and then we're going to figure out how we're going to get to our image using a rotation. Okay, so to find the center of rotation, what I would do is I would just start testing points. Okay, So I might start with that one there. If I hold that on there and rotate it round, does it get to our green shape? No, it doesn't. So that is not our center of rotation. Let's see what happens if we pop it over here. Definitely not. Okay, that's not anywhere near our shape that we need. Okay, so I might try this one here. Okay, we can see that that doesn't quite match up either. So what I would say is, because we know that these two weren't too far off, it's going to be somewhere between the two. So I might try that now. Closer, but still not quite. So I'm going to go with that one there. Okay. There we go. So they line up. So we know that my centre of enlargement is that point there. So that is at -1, 2. Okay. So our centre of rotation is at -1, 2. Okay. And we need to also find out which direction it's rotated in. Okay, so I rotated it round this way. So I started here and I went, oops, I started here and I went 90 degrees in a clockwise direction. So I turned my pivot around 90 degrees. In a clockwise direction. Okay, it's a bit of a trial and error, but you can get there in the end.